Hey guys, happy Friday. We're going to go over the Chapter 20 activity sheet, sections 1, 2, and 3. So go ahead and pull out your iPads, get your assignment up, and we'll begin. In the true-false section, we have false, 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 true, true, false, false, true. Now I'm going to look at the false in particular. When air temperatures fall, right, remember that if the air temperature is falling, that the capacity of the air is going to decrease. That was the beaker experiment that we did. So here it says the air can hold more water vapor, and we just know that would not work, right? We watched the water go into the smaller container, and luckily nobody got wet. All right, the next one. Cloudy days tend to have a greater range of temperature than clear days. If it's a cloudy day, we know the clouds are out there and they're going to actually be blocking out the incoming solar radiation. Therefore, the Earth isn't going to be there to absorb as much energy, and you're not going to get a very large temperature range at all. So if you guys think about a cloudy day, it really doesn't get that warm out, does it? However, we said when you have a clear day, the Earth can absorb a lot of energy, it can get really, really warm, and then at night, if there's still no cloud cover, that energy is actually going to radiate back out into space, and it'll get nice and cool again. All right, next, water vapor condenses when air temperature reaches the dew point. Now, I'm sure many of you were like, true, and you're almost right, except it did not specify that there's a condensation nuclei present. Without a condensation nuclei, you simply reach 100% relative humidity, and then the air becomes supercooled. So dew point really just means that the air is saturated. All right. Number 6, I highlighted advection fog because remember you got the 4 types of fog. The rest of the statement is just defining upslope fog. So make sure you guys go back and review your 4 fog diagrams if you got that one wrong. And then all precipitation falls from clouds. Now the definition in the textbook says that precipitation is water that's fallen from clouds. However, if you look at dew and frost, they're both types of precipitation and they do not need a cloud. So I went with false. Okay? I'm going to pause and change the screen. Okay. How do clouds influence weather? As I just stated at the beginning, clouds can block out incoming solar radiation. Clouds can also trap the re-emitted infrared radiation, and clouds are there for precipitation. So if you guys need to, you can certainly rewatch this video. It will be on my website all weekend where you can read each individual statement, but I'm just going to keep moving. Explain how clouds form. So everybody, let's begin with evaporation. Means that warm, moist air is rising. Moisture in the air becomes less dense, so therefore the air is going to rise. Rising air into the atmosphere means that there's now less pressure. Lowering the pressure means there's expansion. And everybody, expansion equals cooling. Very good. For those that didn't say it, come on, we need a little more class participation. Expansion equals cooling. Cooling now is going to decrease the temperature, therefore raising the relative humidity and bringing you close to the dew point temperature, at which point the relative humidity is 100%. If condensation nuclei are present, condensation will occur, and a cloud will form. Too easy. Next question. Outline how clouds are classified by altitude. Now I know you guys read in the textbook there's high and low and cirrus, alto, and then just regular old low altitude clouds just get the shape or function. So you have high altitude with your cirrus, cirrostratus, cirrocumulus. Come down to the middle altitude and you have altostratus, altocumulus. Drop down to low altitude and you just have stratus, cumulus, stratocumulus, And then remember we need to get some nimbus in there. So we have a nimbostratus, and the one cloud that defies all of them, the cloud of vertical development, that we're of course focusing on right now with our thunderstorms and hurricanes, will be our cumulonimbus. Alright, on to the multiple choice. Weather factors include D, all of the above. Temperature, precipitation, humidity, visibility, wind speed. These are all things that you hear in a standard weather report or on the morning announcements. Alright, the dew point is the temperature at which the air is saturated. And remember that saturated means the relative humidity is 100%. So it should be C. Relative humidity may decrease if, I'll admit right now, A is not the answer. I don't know what I was reading. Should be D. Air pressure increases. Increasing pressure causes compression, and compression equals heating. Remember when I did the bottle demonstration, when I was pumping the air into the bottle actually got warmer. So if we raise the temperature, that means that we're going to increase the capacity of the air, thus decreasing the relative humidity. Which type of clouds or cloud forms at high altitude? When you're looking at this question, you should be looking at high altitudes, which mean we get rid of these, and we're only left with A because it's got the cirro cumulus in there. Cirrus, cirrocumulus, cirrostratus, those are your high altitude clouds. Alright, for the next one, which type of cloud forms when strong air currents? Key point here, strong air currents carry warm air upward, and that's going to be your cumulus cloud. We haven't really gotten into that too much, so I wouldn't stress it, but if you remember how thunderstorms are going to form, you need the cumulus to then get that vertical development. That's the strong air currents. That's the upward development. Alright, the next one, type of fog that forms when cool air moves over a warm lake. So cool air now moving over a warm, moist body, that's going to give you your steam fog. And last one, rain passes through a layer of freezing air. If you guys look in the text, that is classic sleet. Alright, moving on down. Vocab, I'm just going to mention it real quick. You have B, D, E, A, F, G, C. For the sake of time, I'm going to keep going. I know to the person in the back it's like, wait, it's still up there. Alright, and then with these statements here, weather is the condition of the atmosphere at a particular place and time. We've been talking about this for 3 chapters, so you guys should have nailed that one. Weather depends on the amount and location of energy. Stop and think about it. Energy is involved in temperature, it's involved in evaporation, it's involved in condensation. All these different phase changes need the energy. So, how much energy? Where's it going? The average weather, stop. The second you hear that, average weather, you look later in the statement, it says long period of time. You're looking at climate. Again, we've been talking about that for 3 chapters. Basic cloud types are defined on the basis of their shape. Is it a stratus? Is it a cumulus? And remember, once you get the shape down, then it's just putting in the layers. A cloud located at ground level, the one that you guys can all walk through, going to be fog. And the last 2, dew and frost, I haven't really stressed it too much, but at least you have it. Okay, moving along. Again, I'm going to give you the order, and then I'll go back and go over the false statements. So true, false, true, 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 false, true, false. All right, so number 2, temperate zones are ordinarily should say unstable. Unstable. Temperate zones are very unstable. We haven't emphasized that, but it's good information. A squall line forms along an occluded front. No squall lines are associated with cold fronts. And if you guys go back into the text and read about squall lines, it's pretty straightforward. The stormiest, number 10, the stormiest weather usually occurs along a warm front. Absolutely not. Cold fronts, stormiest weather. Because the cold front, like a bulldozer, high pressure smashes out the warm front, sends it upward, causing the cumulonimbus clouds to form. The faster that happens, the stormier the weather, the greater chance you're going to have thunderstorms. All right. What is an air mass? It's a large mass of air that has the sameness or similarity of temperature and humidity. And guys, remember, this is going to cover a very large area. You're talking hundreds to thousands of kilometers. And it can be several kilometers thick as well. What gives an air mass its characteristics? Well, you get the characteristics based on the source region. So let's recall, you can either form over the ocean or over the land. So if it's over the ocean, we call it maritime. If it's over the land, we call it continental. And then the other characteristic, the latitude. If it's at a low latitude from the equator, say up to around the subtropical zone or even the Tropic of Cancer, let's use latitude. That's going to be your tropical climate, so that's going to give us warm temperatures. Then we get into the mid-latitude to upper latitude region, and that's going to give us our polar. And if you're all the way up in the Arctic Circle, up by the poles, that's going to be the Arctic air mass. And then you guys just put them together. Then the question says, where might a warm, moist air mass form? Warm, again, going to be tropical. Moist is going to be over the ocean. So put the two together, you're going to have low latitude over the ocean. Too easy. Next one, why do air masses move? Air masses are going to try and move to seek the balance. So if you have a cold air mass, it's going to push toward a warm air mass toward a cold air mass. Back and forth. I wouldn't stress so much why they move, but rather I want you guys to really understand that when a cold air mass pushes in on a warm air mass, that's going to give you that turbulence. It's going to give you that drastic change and usually stormier weather. By contrast, when the warm air mass slowly overtakes the cold air mass, that's when you're going to get the clouds forming, and then you can get days of cloudy weather or precipitation. Okay, more multiple choice. So, an air mass gets its characteristics from the area where it forms. That's a nice way of saying the source region. An air mass that forms over a polar landmass is likely to have. So polar and land, we're looking at low temperatures and low humidity. Air masses are slowly pushed along by high level winds. All right, Earth's rotation, okay, that's nice. Coriolis effect causes things to deflect to the right, and Earth's gravity, well, that's just a nice statement in there, has nothing to do with the question. What generally happens at any front? I'll be honest, I really don't like this question, but for the sake of time, I'm just going to go with D, and we can argue this another day. The air mass rises. If you're going to have either a warm front hitting a cold front or a cold front hitting a warm front, the warm front's definitely going up, and temperatures fall. That's another discussion that we can get into. All right, for another day. After a cold front passes, the weather is likely to be drier. right? The cold front pushes in, yeah, you get all that heavy precipitation, but then usually you're going to pick up a couple clear days after that. Remember, high pressure, cooler temperatures. One air mass is lifted above two others. That's the occluded front. The cold air mass not only pushes into the warm air mass, but actually merges them with another cold air mass, and the warm air mass rides along. Right? That was the camel analogy that I tried to give you guys. Source region of an air mass labeled MP, or maritime polar, might be the northern Atlantic Ocean. So, higher latitude, out over the ocean. Too easy. Again, vocab, I'm not really going to spend time on it, so B, D, F, G, A, C, E. It'll sit up there for a second as I continue with the fill-in. Air masses typically form in high pressure zones. High pressure zones. Cold air masses tend to flow toward the equator. Just stop and think. You're cooler, you're moving down, high pressure down toward the warmer area, and vice versa. Warm air masses tend to flow toward the poles. All right. Air masses do not mix at a front because they have different densities. Right? You have a low density warm air mass and a high density cold air mass. They're not going to mix. Instead, one's going to push the other one out, and that's why you get that bulldozer effect when the cold front comes in. At a front, one air mass rises above another, causing a low pressure zone. If something's rising, it's going to create low pressure, just like with a hurricane. A cold air mass has greater density than a warm air mass. Too easy, straightforward. An air mass that forms over the ocean will have higher humidity. I think, again, that's straightforward. And more true-false. All right. False, true, false, true, false, 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 true, true, true. So number 1, anticyclones are cyclones that occur in the southern hemisphere. Absolutely not. Anticyclones are a center of high pressure. Cyclones are center of low pressure. When you change hemispheres, you're changing the rotation. So cyclones are going to be counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, and anticyclones are going to be clockwise in the northern hemisphere, but counterclockwise in the southern hemisphere. Right? Little review for you. All right. And for those that have been waiting for it, hurricanes can produce higher winds than tornadoes. That's definitely false. Tornadoes are really small, so they can really get themselves moving quite fast. A really strong hurricane is only going to get up into the 200, maybe 250 kilometers per hour, but tornadoes can get a whole lot faster. Go back and take a look at the Fujita scale for the tornadoes, and then the Saffir-Simpson scale for the hurricanes. You guys will see where those numbers make sense. Good. Number 5, tornado activity in the U.S. is greatest along the East Coast. Absolutely not. The area known as Tornado Alley sits in the middle of the United States. So go back and look at the distribution map in your notes. Category 5 hurricane is described as strong. No, that would actually be a 3 on the Saffir-Simpson Saffir-Simpson scale. All right, next. There are about 40,000 hurricanes around the world each year. Folks, if there were 40,000 hurricanes, we would not be naming them all, right? We expect that if we can get 20 to 25 hurricanes in a year, then that's been a pretty crazy year. All right, that's why we have a naming system, and we'll get a little more detail on that come Monday. All right, question 1. Describe the Northern Hemisphere cyclone. How would a cyclone in the Southern Hemisphere be different? So, cyclone, I don't care where it is, center of low pressure. You're going to get the heavy precipitation, the strong winds. But in the Northern Hemisphere, it's going to be counterclockwise rotation. And in the Southern Hemisphere, it's going to be clockwise rotation. Too easy. Number 2, identify storms caused by mid-latitude cyclones and tropical cyclones. So that you guys can look right back into your notes. Mid-latitude cyclones are going to be your blizzards and your nor'easters. So that's a little more common for us in New York. However, tropical cyclones would be your hurricane, your typhoon, and cyclone if we're in the Indian Ocean. All right, compare and contrast cyclone and anticyclone. As I said before, a cyclone is the center of low pressure. So you get the warm, moist air rising and the counterclockwise rotation in the northern hemisphere. An anticyclone is going to be a center of high pressure. So high pressure usually means you have cool air sinking, and that's going to be clockwise rotation. Good point to remember that with the cyclone and anticyclone, before we talked about lick and hawk. So lick was center of low pressure, inward movement of air, counterclockwise rotation, and then hawk was center of high pressure, outward movement of air, clockwise rotation. Go back and check your notes. It should make sense. All right, we're almost done. Some more multiple choice. Which type of storm is most common worldwide? And that would be thunderstorms. If you guys think about it, that right now, anywhere in the world, as many as 2,000 thunderstorms going on. End quote. All right. Lightning may move. It can move from cloud to cloud. It can move from cloud to ground, or it can move within the cloud. All right. Again, go back and check your notes. That would be D. Characteristics of a northern hemisphere anticyclone include. Now this one, I apologize. It actually had two answers. It would not have rising air, it would actually have sinking air. So that's why I highlighted A and B. I'll fix it for next year. Sorry, guys. The Fujita scale measures storm intensity by wind speed and damage done by the storm. Okay. Again, if you guys go back and look at the chart, it has that information all on there. Tropical cyclones may be called typhoons, cyclones, or hurricanes. So here you only have typhoon, but be prepared for a question like that. Storm surge caused by a hurricane occurs when the low pressure center of the storm comes on land. Now that's that major cause of damage. Hurricanes bring a lot of extra water. They smash into the shoreline, and that extra water causes flooding. If you guys don't understand that, talk to somebody that survived Sandy. They'll tell you all about flooding. All right. To be a blizzard, a storm must have D, all of the above. If you guys go and take a look in the notes, it's going to talk about each one of those. We haven't gotten into blizzards. I'll mention it on Monday. Okay. Again with vocab. F, E, G, D, C, B, A. And then let's take a look at the fill-in. Tornadoes form at the front of severe. Oh boy, that actually didn't make sense. Hold on. My apologies on that. Thunderstorms. Next, cyclones rotate Counterclockwise in the northern hemisphere, most winter storms in New England are caused by mid-latitude cyclones. The low pressure zone of a tropical cyclone is known as a tropical depression. Just a quick note on that. You have continuing thunderstorms that are developing out over the ocean when they create a tropical disturbance. Once you note the tropical disturbance, you start to get some wind speeds that pick up. Now it becomes a tropical depression. Tropical depression then can elevate when the wind speeds get up to 61 kilometers per hour. Now it's a tropical storm, and then it can go all the way up. When it hits 119 kilometers per hour, it's finally a hurricane. Good. Next. Tornadoes are measured on the Fujita scale, and hurricanes are measured on the Saffir-Simpson scale. And then if you guys look back in your notes, I think 2 chapters, heavy snow that falls on the leeward side of the Great Lakes is called lake effect snow. I encourage you guys to take a look at lake effect snow, but basically like the rain shadow desert that we talked about, where the air is going to rise, cool, condense, precipitate, come over the top of the mountain, and then sink down, causing a desert. When you have a mass of air that comes across, so on the windward side of a lake, it's going to move across, it's going to pick up a lot of that moisture from the water, and then when it hits the leeward side, it hits that cold surface again. Now it's going to wring itself out, and that's why you get heavy snowfall in areas like Geneseo. So those of you who are thinking about college in a couple years, upstate New York, you might want to look at where the lake effect snow hits the worst. If you're into skiing, it's great, but if you hate shoveling snow or getting buried in snow, might be a factor. So, now that we've gotten through that, I encourage you all to get started on your weekend assignment. You got that comp review assignment number 5. It's going to take you a little bit of time. And to my colleague, thank you for covering my class today. Hope you have a great weekend.